Well, hello, everybody, and welcome to the GS UK virtual conference. This is the part of the hybrid cloud stream. This is a new stream that we have introduced this year, and I'm pleased to have a number of sessions running in this. So JJ and myself are the chairs of the stream. And this first session is 8A, ensuring the mainframe is an integral part of your enterprise observability strategy. So the session is being recorded and will be available afterwards. It's a 45-minute session, so any questions you have, please submit them into the chat window, and we will pick up on those at the end. And of course, importantly for us is feedback. So providing feedback to the sessions can be done through the agenda abstracts, through the bring your own agenda, or scanning the QR code. So with that, I'll hand over to Chris Walker, who will be presenting the session today. Thank you, Chris.
Thanks, Brian. Good morning, good afternoon, everyone, wherever you may be. My name's Chris Walker. I am a product manager at IBM. I happen to be in the Hersley lab today, but I'm normally based in the US these days. But I'm here to talk about a really important topic, I feel, in where the mainframe is going, which is making sure that we can bring the mainframe into the enterprise observability story that most organizations are thinking about today. As we go through this, I'll introduce some topics around or some use cases around where it's important to bring where the mainframe needs to be as part of the conversation. It helps us with the relevancy of the platform going forward to make sure that as organizations think about their observability strategy, that the mainframe isn't perceived as different or difficult to be part of that. We want to make sure that it's well understood that the mainframe and all of the subsystems and the critical workloads that run on the mainframe are part of that and can be fully visible as we go through this. So just to sort of reiterate this point, and I imagine most of you on this call and in this session fully understand the importance of the mainframe in part of organizations' workloads. We have critical data stored within DB2. We have transactions workloads running within IMS, KICS, other subsystems within there. And organizations are dependent on the mainframe for their business success. But we see a lot of it doesn't operate in a silo, the mainframe. It is part of a very complex hybrid environment that is out there. And what we will see in many cases is that there may be front-end applications or workloads that have been developed and deployed, maybe on public cloud, and they get hooked into the mainframe maybe through web services or gateways like KICS Transaction Gateway, or through API connections through something like a ZOS Connect into there. And so you end up building this very complex network of how an application works within the system. And what organizations are really keen on understanding is what is the transactional journey that a particular flow took. So if a customer is at a web portal or a mobile device, initiates that transaction, what systems did it touch? Where did it go through there? Because and how long did it take at each part? Because understanding that journey is critical to knowing if the application is performing successfully, isolating where problems might be, and ensuring that there is either regulatory SLAs being met, or maybe just customer satisfaction in terms of managing that. So as it's an essential part of this, organizations are spending a lot of time looking at their what we'll call an observability strategy. And we'll go into what we mean by observability shortly. But in a lot of cases, what we find is they have made plans or they've implemented things across public cloud, maybe distributed Linux, VMs, that sort of thing. But often they find that it's been difficult and a challenge to get Z into that story. And so trying to address that is one of the things that I'm focused on in my role, and also something that I think if you're interested in the observability topic, how you should be thinking about how to address this as well. So when we say observability, what do we mean? It's kind of come in as a term in the last 5 years, maybe, around the monitoring and operational APM space. So here's the definition that you can get from Wikipedia, and I've highlighted a couple of parts around that. It talks about distributed computing, and by that it means systems that are interconnected, but not one big monolithical system. But what the critical part is about collecting information about what is being executed and run within those systems, and understanding that communication within that. So it brings in things like logging, tracing, looking at metrics within there as well. And what it has evolved to is really bringing in a new persona or stakeholder involved in this called site reliability engineering, which is understanding how reliable an application is and understanding where the issue might be to do that. Another critical part of that is and I've highlighted here, is around minimizing the amount of prior knowledge. We know that there are people who have lots of deep knowledge about certain technologies within there. But when you start to think about an application that spans lots of different technologies, we've got to be able to understand and triage that as quickly as possible, and not be always dependent on deep dive experts in every single domain in order to fix that particular issue. So putting it another way, these are some of the key things that we find when we start to talk about observability as a topic. The first is actually getting the right data in there. Now, if you're coming from the mainframe background, you know that there's a lot of data out there. You've got monitoring solutions that are collecting data at sub-second levels. You've got SMF, RMF, lots and lots of information out there. What we're focused on within an observability space is to make sure that we actually get the right data to those people. We're not drowning them in data, and we give them things in the right contextual way. So that may be things like, sometimes we'll call them golden signals. So understanding the latency of a transaction as it's running through there, the number of transactions that are being processed, the number of errors that have been seen on the system as well. So that allows us to do initial triages or understanding of how things are doing there. This data needs to be also at the right level of granularity. So, and this is often quite a interesting topic for APM observability solutions, is how often do you collect data? Do you want to collect every single trace flow? Do you want to be able to do sampling in some level in order to cut down on the amount of data that's being done there? But it's important that the data that is actually being collected and the detail of that data being in there is provided within a timely fashion. So this is not looking at something the next day in terms of retrospective SMF analysis. This is about near real-time analysis of how the application is performing, so you can identify issues before the impact is really out there. So this can sometimes be a challenge in order to get that in there, but that's an important part of it. And then to sort of rule back to the last thing that I mentioned on the previous slide, it's the consumability of that data within there. So being able to visualize what is being collected across disparate systems and pulled together will allow people with perhaps more limited understanding of the system to be able to consume and identify where potential problems might be, and hopefully even try to resolve some of them within there. So that's a slight difference between what we might call traditional monitoring and what we observability is. Put another way, observability is about having the visibility into the system and also providing understanding through the context that we're doing. So someone who is using an observability solution will be thinking around, how did the user experience things? What was underpinning those that experience with them? What systems were being run? What was the configuration? What were the programs? What were processes that were involved in that, and what could have contributed? It's a slightly different way of thinking about how we're doing monitoring, as opposed to thinking about, did CPU go high? Okay, what was the impact of the CPU going high? We're actually thinking about a more outside-in approach, where we're thinking, what was impacted, and then what could have caused that impact within the environment. So slightly turning on our heads how we would be thinking about this. And so why do we talk about observability now as opposed to sort of traditional monitoring? And it's really because of the change in how our applications and our infrastructure is being put together. And this is a slide that one of our fellows at IBM, Bala Rajavaran, put together last year, talking about how things have changed within architectures. So if you go back 20, 25 years, we still had traditional data centers where everything was under the control of potentially one team, and it was very easier to manage. The complexity was sort of far less within these environments, because we really weren't probably dabbling our feet in things like API and things in those spaces. But as we went through that first decade of the 21st century, we started to move into things like cloud computing as well. That increased the complexity within that environments. It also split up how we would be managing a lot of this workload. So certainly wouldn't be under one team, but also the nature of the workloads were different as well. We started to see ESBs and applications interacting with each other that may have been developed by different teams. They weren't certainly monolithic in any stretch anymore, and that complexity increased over the next decade. So we start to see microservices and other workloads interacting with each other as well. All of that pushes up the difficulty in terms of managing those systems as well. So the traditional ways of how we would manage an environment suddenly become less useful in terms of how we would do this. We've got different systems within different organizations, with different geographics locations, all working together, but all are part of a complex application environment. And so being able to manage that we need to take an approach around how we think about doing this management. And so putting this another way, this is the evolution from traditional operational monitoring to observability. In the past, we would have these monolithic systems, and the value would often come from being able to provide access to metrics that were hidden away in the black box. There would be operations staff, systems programmers who were very well versed in how this is all working, and they would be the experts in how to fix things. They would be looking for alerts in the system, often static alerts in there, in order to identify which things they should be focusing on. But they probably weren't as application oriented as more infrastructure oriented within there. Over probably, I would say about 15 years ago, we started to see a growth in people using APM solutions, or application performance management, because we were seeing three-tier solutions where there would be front-end applications, middleware, and then sort of systems of records at the back end. Solutions would be built that would cover these, but you would be dependent on the vendor in order to provide collection and management and coverage across that. It helped people like application developers understand how their applications were working. It also helped business teams understand where things were, but there was still a dependency on a single vendor to provide the full end-to-end view. And now we're into this observability view, as we've already spoken about. So as we see these native, containerized, monolithic systems out there, non-monolithic systems, microservices, integrating different forms of communicating between each other, we need to be able to have the right level of telemetry for real-time analysis, and that's where the site reliability engineers starts to come in. And what this means ultimately is that when we have these hybrid applications, there's multiple teams involved and multiple stakeholders who are all involved in the success of that application. We've spoken a little bit about the SRE being responsible for the availability of the application and the performance of it and the reliability of it. They will have a limited understanding of every single technology in there. I suspect they would have very limited understanding of mainframes in a lot of cases. But ultimately, if a system is struggling, they're the ones who are on point to initially understand where the problem is and understand who should be involved in doing it. We have people who are looking at non-Z IT operations, perhaps things how are running on cloud and distributed hardware in there. So they're interested in how this application is running. I mentioned earlier application developers. So traditionally, application developers had a very limited view of what is occurring in production environments. They would be doing their updates, coding their features, pushing things out. They may have done some testing, integration testing, but ultimately there may be blind spots that aren't really covered in their end-to-end testing, and how impact to production performance. To think of an example where app development can have impact and maybe missing something, but would have an impact in production is, well, maybe they put a cool new feature into the front end of the application, which results in an additional API call, which results in an additional call to read something from a DB2 tape. That's obviously going to impact production performance in the Z side, but it was triggered by something that has changed in the front end application. So we need to be able to have that full end-to-end view to support app development and changes that are being pushed in there. And we also have our traditional mainframe subject matter experts who have that deep skill in ZOS-based workloads and their environments. They may use tools like Omegamon today, and they still will in the future, because Omegamon gives things like, deep sub-second access to very detailed information, like what's being put on temporary storage or what's been triggered in an environment. So there is a role for that level of detail in there. But often in the past, they have limited visibility outside of the mainframe, so they don't understand the full context of the applications which are running within shared environments like you see on the mainframe. And the result of this, obviously, is that they all have their own perspective on what's going on and their own tooling as well. So everyone has got a view of what's occurring within their domain. That data may be collected at different intervals, have different levels of granularity, different views within things. And so it can be difficult to then turn around and understand, where to focus on, because what may look okay in someone's domain may be looking like a problem in another as well. So being able to address that is a major challenge. So I mentioned early on that organizations have been working hard to build out a enterprise observability strategy, but really struggle to get the mainframe into that story. So let's look at what happens when you don't have that end-to-end view. So our SRE here has got a nice view of their applications. They can see it in the transaction navigating through different services. And they get an alert that says actually the application is not performing as well as it had been. The bit that is highlighted here is actually the mainframe, and it's actually just showing you exactly that the call went into the mainframe and it came out slower than it has been in the past. So there seems to be a problem on the mainframe. The challenge is that we've got the mainframe represented here as a single node. It doesn't tell you any context about where it went in the mainframe, what subsystems it touched, where and which instances of those subsystems were involved. So as far as you can tell, it's a problem on the mainframe, and we need to work out what is actually happening there. So who do you call in that situation? Well, if you don't know who to call, then you've kind of got to call everyone. And sometimes you call these a war room or some kind of bridge call or some kind of investigation area because we're not sure how to isolate this. So maybe last week MQ was a problem. So we'll call the MQ team and they can do their investigation. And it's looking good according to their environments, not their problem this week. The IMS team takes a look as well. They're doing investigations with their tools. They don't think that that's part of the problem. Eventually, we do get to the root cause, and maybe one of our KICS regions was short on storage for some other region, and it's experiencing a slowdown that's impacting our application. Our KICS subject matter expert is able to fix things and get things back to normal. But the problem has been that the amount of time that it's taken and the resources taken to get to this point. We've had to call lots of people onto a call. They've had to go off and do their investigations to kind of prove their innocence. And what this results is time that potentially is impacting end users within that, and an unsatisfactory situation. So what we bring in and what we need to bring in is making sure that the mainframe is a first-class participant in that observability story. So as we bring this in, it's almost unremarkable, but it is very remarkable how, what we're delivering here, rather than having the mainframe as a isolated black box without any context within there. We make sure that the mainframe components are able to be seen just like any other part of the application flow. So instead of seeing a mainframe here, we can actually see that the call went into MQ and then to KICS and then to DB2. And in this case now, instead of just highlighting a mainframe as an alert, it's actually telling us, this KICS region or a KICS problem has been occurring. And so we can actually immediately go to the KICS team because we've isolated that issue or the symptom of the issue to KICS at this point. And of course, we're not just going to just throw the problem over the wall and say, KICS team, go and investigate. They may have dozens, if not more, KICS regions under their control, and they may have lots of different alerts or things that they may be looking at in terms of the infrastructure in KICS. We need to be able to provide them the context around the applications that they're managing in order to address the issue quickly. So we want to be able to say, look, we've seen our applications being impacted by something that's happening on KICS region, KICS T11A. Task number 56177 is associated with this. It looks like the transaction rate has dropped on this environment. So our KICS subject matter expert, they may use their tool of choice, like a Megamon, and go in there. They can immediately go and try and resolve the problem that's impacting that KICS region, hopefully before there's end user impact within there. And we've cut out a lot of time that's spent trying to triage the issue. We've also not had to bring in teams that aren't directly impacted in this in order to prove their innocence. And so we've reduced the amount of friction within the time to detect and isolate the problem. And then hopefully that leads to a reduction in time to resolve the problem as well. So, as I say, I mentioned, the challenge of bringing in Z into the enterprise observability story. And that is something that's at the forefront of a lot of organizations. And here's just a couple of some surveys from last year that reiterate that point. The first being that, we are building applications today that span different environments. There will be a hybrid world where we have public cloud, mainframe, and other assets out there, each bringing their own strengths to the application, and they will be working together in order to provide the best experience to end users and customers. And by leading to that, our operations teams are being challenged, and it is highly important to be able to visualize and monitor and have a view across that hybrid environment within a single dashboard or some kind of consolidated view within there. So while that is important, we still find that lots of organizations are finding it difficult to do that at the same time. And that's one of the things that we are working towards to try and resolve this. I want to talk a little bit about now a topic that's become very important in that last sort of 5 years as observability grows, and that's open telemetry. Because as we've seen growth around standards for other parts of IT, there is now a demand for standards around telemetry and monitoring. So as we try to avoid blind spots in our environment, we want to have a consistency across there. And so many have pointed to open telemetry as the potential solution here. So I'll do a very quick overview of what open telemetry is. Again, it's something that has evolved in the last 5 years or so and is a vendor agnostic framework for doing observability across environments. There are various components and specifications within open telemetry. And I won't go into all of them. However, the main focus of trying to use open telemetry is to bring a single standard that collects required data to allow us to do that end-to-end view within things. It hopefully will in time reduce the need for different types of collection agents, different types of solutions in doing that. And by following standards, there's interoperability between the systems. So in terms of tracking a transaction. So if we look at something like an application that goes from cloud to Linux to Z, there will be standards that can be applied and gathered across all the components that are running across all these different systems, such that they can be pulled together and ultimately visualized together because they're all complying with this standard. Now, what this isn't is a product in itself, but actually is a standard that's being used. It's become very important, and we can see the popularity of it. So as it started, well, 6 years ago now, it is under the control of the Cloud Native Computing Foundation, which manages lots of different open source projects within there. And this is a chart from last year, and you can see this chart sort of shows the number of I think it's commits and usage within the different projects. Two projects really stand out at that top right corner there. One is Kubernetes, the blue circle, and the red one is OpenTelemetry. And that is because we've seen the demand required to do this. We're seeing a lot of vendors, including IBM, adopt OpenTelemetry across various solutions because there are now demands from organizations and clients in order to adopt OpenTelemetry as a standard within many, many solutions. And what this really means then is that we move further and further away from a monolithical structure where observability or monitoring solutions would be responsible for everything from data collection, management of that data, any analysis on that data, and then visualization, reporting, alerting on that, to more focus on those higher level things, whereas data collection and interaction and managing the interactions between systems will be covered by the OpenTelemetry protocol. And then the observability backends or the monitoring solutions really would be responsible for acting on that data and understanding and analyzing it and providing the higher value on that. So this is where they achieve differentiation by providing those advanced analysis and correlation capabilities. When we look at observability and open telemetry, we often talk about there's certain terms that are often used quite often, and these are different types of data that can be collected through open telemetry, and we sometimes refer to these as signals. So often we hear about metrics, traces, and logs. Metric would be something like a measurement of something that occurred at runtime, a CPU level at this point, or the amount of storage that's being collected. The trace represents a path through a particular system and allows us to understand, a transaction arrived here or a task arrived here, and then where it went to afterwards. And then we can trace stitch tracing parts together. A log is obviously a time-stamped record with some detailed information about what is occurring in that system. OpenTelemetry is now starting to look at profiling as well. So that is a means of looking at performance and behavior of application code at runtime. And on top of that, we also have baggage as well, which would be contextual information that can be added to any of these signal types in order to add additional context to what is being passed there. And these are fairly well used terms within the OpenTelemetry specification. So we're going to focus a little bit more on tracing in the next 10, 15 minutes as we finish up here, and how distributed tracing is coming in, because that's the key use case that I think most organizations are looking for, to be able to expand what might be a distributed application outside of the mainframe coming into Z. So the application has a lifetime. Oh, the transactional of the application lasts a particular period of time, and we want to be able to understand the time it's spent within different systems. And in this environment, we've got a couple of MQ queues and a couple of kicks regions and a DB2 within there. And so we want to be able to get that breakdown as the request goes in, and as the response comes back within there. So as the transaction passes through the system, being implemented with OpenTelemetry means that there will be a trace context that is passed between all of these systems. The trace context identifies the actual transaction individually, but each participant in here would also create what we call spans within there, so that we can understand the relationship between each of them, the parent and child. So MQ going to MQ, going to kicks, going to kicks, going to DB2, and the relative timings and maybe other interesting information that might have occurred within that system. So as the transaction passes through there, being instrumented with OpenTelemetry, these spans will be created and they will be sent back, and in your choice of observability solution that is consuming the OpenTelemetry data, you can build up a view of what is occurring within that environment. So in this case, while that full application takes the length of the purple line, you will see the breakdown of each in that time period of where it was spent going through there. And obviously, if there are delays or changes in behavior of transactions over time, you're able to get that breakdown in terms of where the delay is occurring and what is the likely place to focus our issue on. So why is this important for Z to do this? Because we've seen this adopted quite quickly outside of Z, because they have things like microservices workloads within there and things. So most importantly, it's making sure that the mainframe is integrated in here. We need to be able to have that end-to-end view. If you have the mainframe not part of it, then as we've seen, there are challenges in terms of getting the right people to focus things on quickly. It's got to be able to help us address issues that are occurring in real time that are impacting end users. We have actually seen a few customers actually, in the last 2 years, make a big step towards OpenTelemetry. We're seeing people wanting to bring their mainframe data into their solutions and use OpenTelemetry as a means of doing that. It is going to help make these signal informations far more accessible, far more usable, and shareable across the enterprise. Yes, the most important use case perhaps at this stage is to show the end-to-end transactional view, but this data is also going to be able to be portable and used elsewhere in different solutions as well, and consumed across other solutions. So the platform itself is focusing on a community approach, because OpenTelemetry is a community-driven solution. and is managed by the CNCF project. So we have a IBM Z focused special interest group that is looking at how open telemetry can be adopted across Z, and that's includes IBM, but it also includes other vendors in that space as well who are contributing and helping direct the adoption of open telemetry. These will be things like, in longer term, perhaps looking at SDKs for Z specific languages, but making sure that Z is represented extensively. On top of that, IBM and vendors will be building solutions that actually will implement and use open telemetry on top of that. And we've already started to see that occur in the marketplace. One of these is within IBM's Z AIOps portfolio, where we have announced support with ZAPM Connect to emit OpenTelemetry tracebands as part of expanded support for transaction tracing. This also feeds into Instana as well, which is IBM's solution that goes through there. So how does this actually work in a practical sense? So if you have a distributed application that is being tracked and traced by OpenTelemetry outside of Z, it will be passing a trace parent along as it goes through the different systems, and that includes the calls into the mainframe environment. So within the mainframe environment, we look for that trace parent, we generate events if we see that, and ultimately we export OpenTelemetry formatted tracebands coming from the mainframe. These can then be correlated with the tracebands that are coming from OpenTelemetry agents running outside of the platform as well. Once they are correlated together, they can then be sent to any number of different solutions. Instana and AppDynamics are two of them, but any number of vendors out there are now, as I said, that are claiming OpenTelemetry support. So all of those different endpoints can receive that data and show the full end-to-end trace of both the distributed parts, which are done by any kind of OpenTelemetry agent, and the Z parts, which are done by ZAPM Connect. What this results in is that you need to look at the different capabilities that the actual end product will be delivering in order to do this. Instana is one of those. This is the IBM solution in this space. So it allows you to have a single pane of glass of that full end-to-end view. Where it focuses on and what other ISV solutions focus on is then what you do with the data, the analysis that it provides on top of that, and the automation and actions that you can take from that. So within Instana's capabilities, we showed the ability to go through Kik, through IMS, through DB2, through WebSphere. We're also able to bring in infrastructure metrics from other solutions as well, either through OpenTelemetry or through native capabilities as well. Now, what tracing does is not a replication of deep dive monitoring, because we want to be very we're very cognizant of the impact on latency, on transaction throughput. You really want to get the most interesting information about the system to allow you to identify where the transaction is flowing from system to system and what was going on within there. Once you've identified and isolated where the problem might be, then you can go into that deep dive and look at that. So what you're really looking for is things like, what was the task number? What was the transaction that was run? Where did it come from? Where is it going to? And how much time did it take? Was there an event code as you go through this? The other thing that you can start to then also do with these solutions is also bring in metrics from the infrastructure to underpin the transaction flow, so you understand what's happening with the application. So a Megamon is used at a very deep level by solutions within by systems programmers. What you end up seeing is that actually there is value in making some of that data available to other consumers, like our SRE, for example. So they won't be interested in real deep dive information. I sort of mentioned things like temporary storage queues and other parts that are quite detailed information, but they will be interested in things like the golden signals of what's occurring within that, and that's already being collected by our monitors today. So being able to integrate that data with the transaction tracing helps us build up that observability view, and also how help isolate and provide the context that allows us to do this.
Just let you know you've got just under 5 minutes, Chris.
Okay, thanks. So if we link from, we bring together tracing and metrics together, someone can actually look at it who's not potentially a big mainframe expert, but they can understand if there is a problem in the system, isolate and go, yes, I need to go and talk to my Kix subject matter expert in this place to go and address this, or no, it's not a problem actually in Kix. Kix is looking fine. Maybe there's some other reason for why we're seeing application problems within there. So one example here is bringing in the Megamon data. That is done through a solution called the Megamon Data Provider. That allows you to pull out information from a Megamon agents. You define which attributes you want to send there, and you can send that to Instana or to another OpenTelemetry endpoint as well, in order to feed that selected metrics within there. The added bonus is that these are the same data between the different personas are looking at. So as your SME is looking at it in a traditional way through their normal interface, your SRE is getting access to some of the key metrics from that, collected from the same agents. So you're actually comparing apples with apples when you're looking at even in different solutions than there, because the source data is actually identical. So today you can also bring all this in with OpenTelemetry. I've mentioned ZAPM Connect and a Megamon data provider here. They are providing OpenTelemetry from the mainframe into there, and it allows you to now bring the mainframe into the full observability story as you go through there. And this will evolve. This is a journey, but it will move forward within there. So in summary, I've spoken a lot about what observability is in this session today. It is a relatively new term, but it is a critical part of what organizations are focusing on today. It focuses very much on an outside-in view that allows us to look at what is the critical business applications that we want to be able to manage and help monitor those more effectively. Z has to be part of that discussion. And so it's essential to bring in platforms like the mainframe in order to deliver that full, what we might call mobile to mainframe insights from there. Not having the mainframe in there is not healthy for the platform, but also is not healthy individually for those applications within there, because it drives up the time to detect and isolate where the problem is and ultimately resolve them. Within the topic of observability, we have OpenTelemetry that's emerged in the last 5 years, and that's focused on being an open standard to define and manage telemetry data within there. While that is a standard to think about, there are different observability backends or servers or products that can take OpenTelemetry data, and each have their own different strengths and advantages. The value comes from what they do with that data as it comes in there. And in the last few minutes, I just sort of spoke a little bit about ZAPM Connect and Instana, which are IBM solutions in that space. There are others from other vendors as well in order to manage and project that data as well. So with that, I'll turn it back to you, Brian, if we have any questions.
All right, thank you very much, Chris. There's been no questions or comments in the chat, unless anybody has anything to ask. Doesn't look like it. Okay, well, oh, here we go. No, it's just feedback. Thanks for your session. All right, yeah, and I'd echo that. Thanks, Tom. So yeah, Chris, really appreciate the session. Very useful insight on, let's say, the challenges and obviously the capabilities that we have. And I think it's really important, certainly in hybrid, as you said at the beginning, that we have capabilities across the mainframe equal to everything that we've got across the rest of the enterprise. So All right. Thank you very much. And once again, I'll remind all attendees, if you could share feedback, that would be very valuable for Chris individually, but all of us as we run these events and make sure that we're delivering the right content. So
Thank you very much.
All right. Thank you very much, Chris.
Cheers. Thank you.
JJ.
Hello.
Can I ask you to end the session? For some reason, I got kicked out. Thankfully, you were made the host, but I now can't end the session.
Yes, I was going to say, I think I have to do it. I want to see you in the next one, Brian.
No problem.
But yeah, I'll be chairing the lunchtime ones.
All right. Yeah, I may be able to join, but I need to be traveling as well. So
yeah, no problem.
Picking that up.
Great. I'll see you later.
All right. Cheers.